Hello class 7. Yesterday we talked about desirable and undesirable change, reversible and irreversible changes. Today we will talk about the main concept of the chapter is physical and chemical change. So we'll deal with physical and chemical changes. Okay. So when we talk about physical change, now what is physical change? A physical change is a change in which no new substance is formed, and it is a reversible change. Okay, so physical change is a change in which no new substance is formed. It is a temporary change and it is reversible change. So all change of state of matter are physical changes. So when we talk about some of the examples of physical change, like any change of state of matter, whether be it melting, freezing, boiling or condensation, these are physical changes. So when we talk about melting, what is melting? Melting is the change of state of matter from solid to liquid on heating, obviously. So that is melting. When we talk about freezing or solidification, it is the change of liquid into a solid state on cooling. So it is a physical change. Similarly, boiling. Boiling is a change of state from liquid to gas or its vapor at a particular temperature, at its boiling point. So that is called boiling. Boiling is actually changing of liquid to its vapor is known as boiling. And the last one is condensation, changing of gases back into liquid is called condensation. So all the physical states of matter, solid, liquid, gas, they interchange among themselves. So if you heat a solid, it changes into liquid. If you cool a liquid, it changes into solid. If you heat a liquid, it changes into gas. Or if you cool the gas, it changes into liquid. Or maybe sublimation, we call it, change of state from liquid, from solid directly to gas. That is sublimation. So all these physical states, change of physical states of matter is or are physical changes. So all change of state of matter are physical changes. For example, when a water is cooled, it changes into ice. When left in the open, the ice will start melting and changes into liquid, and so on and so forth. So the properties of ice and water are the same, that is, no new substance is formed. So in a physical change, any physical change, no new substance is formed. Okay, the property of a substance will not change. So that is a physical change. Like you dissolve water in water, you put a little bit of sugar, it will dissolve in water. So therefore it is a physical change in which no new substance is formed. So dissolution of any substance, soluble substance, is a physical change. So the basic unit of water is a molecule of water. Hence ice is composed of water, H2O. So no new substance is formed. Whether you melt ice, the formula is still H2O. Whether be it water, the formula is still H2O. So melting of ice, freezing of water, boiling of water, condensation of vapors, these are all physical changes. Why? Because no new substance is formed and it is a reversible change. The chemical composition of matter doesn't change in a physical change. Now we come to dissolution of sodium chloride in water, as I already told you. So we put salt in water, it dissolves. So when sodium chloride dissolves in water, a salt solution is obtained. Now heat the salt solution, you get back the water will evaporate and you get back the salt. So it can be reversed by reversing the condition. So therefore it is a physical change. Similarly, ammonium chloride or iodine or naphthalene, they all sublime on heating will change directly into gas. Sublimation is a process of changing solid directly into gas. So ammonium chloride sublimes on heating. So you can get back solid ammonium chloride from its vapors on cooling. So let us talk about now the characteristics of physical change. Number one, generally the change is temporary and reversible. Number two, no new substance or substances are formed. The physical composition, the chemical composition of the substance will remain the same. There is no alteration in the chemical property or the chemical composition. And number four, the physical change may cause changes in the state, shape, size and the color, but chemically it remains the same. So these are the properties of physical change. Some examples. So let us talk about some of the examples of physical change. Glowing of electric bulb. So what kind of a change is it? It is a temporary change. It's not a permanent change. So you can change the condition. If you change the condition, it will again stop glowing. Like if you switch off the switch, the electric bulb will stop glowing. So it is a temporary and a reversible change. That is, it's not a permanent change. So therefore, it is a physical change. So no new substance is formed. Magnetization of piece of iron. Now you turn a piece of iron into a magnet. How do you do that? Is you rub. Suppose you have a piece of iron here. There's no normal piece of iron, and here on my right hand I have, let's say it's a magnet. Now how do you magnetize this piece of iron? Is you rub it from one end in one direction, one end in one direction this way, and this piece of iron, after several repetition, it becomes a magnet. So this magnetizing of iron is also a physical change because it is a temporary change. Okay, and no new substance is formed. The chemical property of iron will remain the same. So therefore, magnetizing of iron is a physical change. Now, breaking of a glass tub, or you breaking of anything, like I break a piece of chalk into two pieces or grind it into powder, it remains the same. It will not change. The chemical property physically, physically it may look different, but chemically it is the same. So therefore, breaking of anything, okay, is a physical change because no new substance is formed. There is no alteration in the chemical property of that particular substance. So breaking of glass tumbler or breaking of any substance is a physical change, purely a physical change. Drying of wet clothes, another example. This is what? It's a physical change. Similarly, sublimation. As I already told you, sublimation is the process of changing solid directly into gas or gas directly into solid. So some of the substances that sublime on heating are iodine, naphthalene, camphor and ammonium chloride. These are some of the substances that sublime on heating. And sublimation, like freezing, melting and boiling, is a physical change because it is a temporary change. It can be reversed, and chemically there is no change. So in the chemical composition, there is no change in the chemical composition. So therefore, the sublimation is a physical change. So some more examples we will talk about. Some more examples of the physical change. They are melting of wax. I'm referring to the book. Melting of wax. Suppose you burn a candle, the wax melting. We are not talking here about the burning. I'm just talking about melting of wax. When you heat wax, it will melt. So it is melting of wax or melting of butter, melting anything, melting of ice, anything is purely a physical change. Why? Because it's a temporary change, and number two, there is no change in the chemical composition and no new substances formed. So that's why melting of anything, may it be wax or ice or butter, anything, it is a physical change. Next is expansion and contraction of substances on heating. Suppose, like we know thermal expansion, you will talk about it in physics later, thermal expansion. So when you heat anything, a solid, it will expand. The size of that particular substance will grow a little bit bigger. You may not notice, but yes, there is a change in the size. So that is called expansion, thermal expansion or thermal contraction. When you cool that metal, let's talk about metals. When you cool the metal, it will again contract. So expansion and contraction is purely a physical change. Why? Because there is no alteration in the chemical property of that particular metal or that particular substance which is contracting or expanding. Tearing a piece of paper, you tear the piece of paper into bits of pieces, there is no change chemically. So therefore, it is a physical change. It may not be reversed. This tearing of paper, if you tear paper into pieces, that pieces you cannot stick it together and becomes a large piece of paper. It actually was. So even though it is not reversible, but it is a physical change purely because the chemical property of that particular substance does not change. So there is no alteration in the chemical property of paper. So therefore we consider it as tearing of paper as a physical change. Stretching of rubber band. As we all know, you stretch a rubber band, the shape changes, but no new substance is formed. So therefore, stretching of rubber band is purely a physical change. And last but not the least, we talk about ringing of electric bell. So ringing of electric bell obviously is a physical change. So we'll talk about one last point in the class, today's class. Key points here. Evaporation refers to the change of state from liquid to vapor at a temperature below the boiling point of liquid. Now, when we talk about boiling, we talk about evaporation as well. It's almost the same. I'm not saying they are the same. We'll talk here about, I'll give you the differences between, some of the important differences between evaporation and boiling. Evaporation is the change of state from liquid to gas. Boiling is also the change of state from liquid to gas. So what is the difference? Boiling takes place at a particular temperature, whereas evaporation takes place at all temperature. It does not take place at any fixed temperature. So that is the difference between boiling and evaporation. So you must have seen the boiling of water and evaporation from a hot cup of milk or tea or water, isn't it? So in both the cases, the liquid is changing into gas, but the difference is boiling is taking place at a particular temperature. Let's say water, if it is boiling, then it boils normally at 100 degrees Celsius. But even if the water is not at 100 degrees Celsius, you will always see if it is cooling down from 100 to 80 to 70 to 60, you will see the evaporation taking place. So evaporation does not take place at a fixed temperature, whereas boiling takes place at a fixed temperature. Evaporation, other differences is not given in the book. I'm telling you, boiling is a rapid process. Boiling is a rapid process, whereas evaporation is a very, very slow process. So you must have seen the water boiling in the kettle. You will see a lot of steam coming out from the mouth of the kettle. But if you compare it with the evaporation, evaporation is a very, very slow process. Very little bit of liquid molecules will escape as gases from the surface. And the last point for you to remember, as far as we consider the differences between boiling and evaporation is, the last point is, the difference is, boiling takes place from the entire surface of the liquid. Boiling takes place from the entire part of the liquid, whereas evaporation takes place only from the surface of the liquid. So I'm sure you have got the difference between boiling and evaporation. Both of them are physical change. It's state of physical change or physical, there's a change in the physical state of matter. So therefore, boiling and evaporation is considered as physical change. So I will not take much of your time. So in the next class, we will talk about the chemical change and the properties of chemical change and the changes involving energy. So I hope you understand and enjoyed the short class today. Thank you so much.